All right, here we're going to go ahead and do the you try problems, examples 24 and 25 for the mean absolute deviation. This was the longest of the processes, and the whole point of the mean absolute deviation is I want to know the average distance the scores are from the mean. So if we look at what we're doing, mean absolute deviation, it says find mean absolute deviation, find the mean first, find the absolute value of the distance, and then you're going to add those distances together and find a mean again. So the first part we've been doing, so we would just want to find the mean. I'm using the symbol X bar here because remember from our notes yesterday that means mean. So we have 12 plus 15 plus 10 plus 20 plus 13 plus 8. And there are a total of 6 scores. So when I do this and I add everything all up together, I ended up with a mean of 13. Okay? Mean absolute. I want to find the absolute distance from the mean from each of these scores. Now distance is always a positive number, so we're looking for the absolute value of this. So I showed it in the notes as we take the mean minus the score. So I want the absolute value of that. Well, 13 minus 12 is 1. And I showed it as the absolute value of 1 is just 1 because I want to know distance, and distance is never negative. So to kind of shortcut this down, I was suggesting to you guys as I talked to you during the day that you can do each one. 13 minus 15 is going to be negative 2. But I don't want the negative, I just want the positive version of it. So we have 13 minus 10 equals 3. So we can just kind of start ignoring the negatives because we're talking about distance here. We have 13 minus 20 would be negative 7, but it's a distance, so it's going to be a positive 7. 13 minus 13 is going to be 0. And 13 minus 8 is going to be 5. So these are the distances that each of these numbers are from this mean. So I want to take those numbers and I want to find the mean average of those numbers. So I have 1 plus 2 plus 3 plus 7. 0 is a number. It's saying there is no difference in the distances, so it's an important number. You don't want to drop it off. 5. And there's still 1, 2, 3, 4, 5, 6 numbers to help me find my average. So when I worked this out, I got a MAD of 3. So the average distance these numbers are from the mean is 3. Okay? So example 25, it was a little uglier. It's not as pretty, and only because there's decimals, it's not that big a deal. When I found the mean, I'm going to skip working it out because we haven't worked how to find mean up here. I got 8.6. Okay, then we're going to take 8.6 minus each of these numbers, 8.6 minus 8.4, and I got 0.2. 8.6 minus 7.9, and I got 0.7. Remember, I'm ignoring any negative signs that come up. I got 8.6 minus 9.1. Would be a negative 0.5, but I'm talking distance, so I'm just going to make it be positive 0.5. 8.6 minus 8.7 equals 0.1. 8.6 minus 9.1. Again, that's going to be negative. I'm just ignoring any negatives. 8.6 minus 8.6 is 0. All right, so these are my distances, and I want to find the average distance. So I'm going to take each distance to find my MAD. 0.2 plus 0.7 plus 0.5 plus 0.1 plus 0.5 plus 0 divided by, there's still 6 numbers, divided by 6 will give me a MAD of 0.333, or you could have written it 0.3 because it's going to keep going. So the average distance each of these scores are from the mean is 0.333 repeating. Hopefully that helps clarify. If you have any questions, be sure you ask me about them tomorrow. See you then.